All right, welcome to this explainer on the hidden economic forces that literally shape our world. Today, we're going to map out the invisible data streams that standard market models tend to just completely ignore. We're talking about the hidden costs and the hidden benefits that are happening every single day right under our noses.
For centuries, economists have absolutely marveled at Adam Smith's idea of the invisible hand. The concept that buyers and sellers acting purely out of their own self-interest can efficiently guide the market. But as powerful as that invisible hand is, it definitely has some blind spots. So today, we're activating a sort of high-tech interface to uncover the hidden signals that the invisible hand misses, because it definitely doesn't account for everyone.
So here's our system diagnostic for today. We'll hit 5 key areas. First, market blind spots. Second, the true cost of pollution. Third, technology spillovers. Fourth, upgrading public policy. And finally, decentralized private solutions.
Okay, Section 1, Market Blind Spots, when the invisible hand fails. Let's jump right into this baseline anomaly in our economic framework.
This brings us to a fundamental concept, the externality. So, what is that? Well, an externality is basically an uncompensated impact on a bystander. Think of it like a hidden glitch in a free market's pricing algorithm. When buyers and sellers completely ignore the external effects of their actions, the market equilibrium isn't truly efficient anymore. It basically fails to maximize the total benefit to society as a whole.
Moving on to Section 2, the true cost of pollution, or negative externalities. Let's filter our data to look specifically at the downward trending anomalies. Have you ever been kept awake by a neighbor's aggressively barking dog? Or maybe you've had to choke down exhaust fumes walking next to heavy traffic? If so, you have directly experienced a negative externality. In these cases, the self-interested parties, like the dog owner or the driver, they just aren't bearing the full cost of their actions. And because they ignore that external cost, the market naturally produces a much larger quantity of these annoying activities than society actually wants. To really visualize this, imagine an aluminum factory. For every single unit of aluminum they produce, smoke goes up into the atmosphere, creating very real health risks for the people breathing that air. To find the true cost here, we have to basically superimpose a holographic layer of social cost right over the standard private costs of the factory. That social cost, it's the factory's private costs plus the external costs to the bystanders, and seeing them together reveals a massive market inefficiency.
Looking at the data, this true social cost curve actually sits much higher than the standard supply curve. The gap right there between them, that literally represents the external cost of the pollution. Because the social cost is higher, its optimal intersection with consumer demand happens further to the left, meaning the socially optimal quantity of aluminum is actually much smaller than what the free market produces on its own.
Let's recalibrate for Section 3, technology spillovers. Positive externalities. Because hey, not all hidden data is bad.
Now we're entering the realm of the positive externality. Whether it's developers restoring historic buildings so we can all enjoy their beauty as we walk by, or individuals getting a higher education, which generally leads to a more informed voting populace and lower crime rates, these actions generate tremendous external benefits. But because the individuals doing these things don't capture all that value themselves, the free market actually produces a smaller quantity of these goods than society genuinely wants.
A perfect example from our source material is the robotics industry. When a firm invests in building an industrial robot, they often stumble upon new, better designs. This creates what economists call a technology spillover. That brand new design upgrades society's entire pool of technological knowledge, which in turn benefits other producers. So to fix the market failure here and boost production up to the optimal quantity, governments might actually step in and offer a subsidy to internalize this positive externality.
Which leads us perfectly into Section 4, Upgrading Public Policy, Fixing the Market. So how do we actually reprogram the market to account for these things?
Governments basically have 2 main tools they can use to patch a market. They can use a brute force approach with command and control regulations, which directly dictate behavior, like just flat out making it a crime to dump poisonous chemicals. Or they can deploy more elegant market-based policies. These try to align private incentives with social efficiency, usually by using taxes or subsidies.
Let's put some numbers to this because the math is actually fascinating. Imagine the EPA wants to reduce pollution from 2 places, a paper mill and a steel mill, both currently dumping 500 tons of glop into a river. A command and control regulation might strictly limit each factory to 300 tons. Simple, right? Well, it's actually way less efficient than a market-based approach, like a $50,000 tax per ton of glop. The tax lets the market organically find the absolute cheapest way to reduce the pollution, shifting the burden of reduction to the factory that can pull it off at the lowest cost.
This market-based approach is known as a corrective tax, or a Pigovian tax, named after the early economist Arthur Pigou. Now, unlike your standard income taxes, which actually distort incentives and cause deadweight losses, corrective taxes enhance economic efficiency. They force decision-makers to account for the bystanders by essentially putting a price tag on the right to pollute. Plus, they give factories a constant burning incentive to invent cleaner technologies just to avoid paying the tax.
And this logic builds directly into another brilliant market-based solution, tradable pollution permits. This is a super clean three-step system. First, the government sets a hard cap on the total allowed pollution. Second, they issue or auction off permits for that exact amount. And third, they allow firms to freely trade these permits on the open market. This completely internalizes the externality by turning pollution itself into a highly structured, tradable commodity. Firms that face high costs to reduce pollution, they'll just buy the permits. But firms that can clean up cheaply, they'll reduce their emissions and sell their extra permits for a profit. It's a win-win.
And that brings us to Section 5, Decentralized Private Solutions. Because, as it turns out, government intervention isn't the only patch available.
We actually see private fixes every single day. From simple moral codes and social sanctions, like, following the golden rule and not littering just because it's a jerky thing to do, to the massive efforts of charitable organizations. Sometimes businesses even integrate to solve this natively. For example, an apple orchard and the neighboring beekeeper might just merge their businesses so their positive externalities perfectly support each other. Or interested parties can always just sit down and draft private contracts to sort it out.
The sheer power of these private negotiations is perfectly captured by something called the Coase theorem. This is a famous economic proposition stating that if private parties can bargain without cost over the allocation of resources, they will basically always negotiate their way to an efficient, optimal outcome. The private market will actually fix the glitch and reach the efficient outcome totally on its own, regardless of who actually held the initial rights.
But, yeah, there's always a catch, right? That catch is transaction costs. If there are too many interested parties, say one massive factory polluting the air breathed by tens of thousands of different residents, transaction costs just skyrocket. These are the logistical expenses incurred while agreeing to and executing a bargain. When those costs are too high, the whole bargaining interface basically crashes. The Coase theorem fails, and the inefficiency sticks around, and that is exactly when public policy has to step back in.
Ultimately, the invisible hand is incredibly powerful, but it's not omnipotent. By utilizing corrective taxes, pollution permits, or private bargaining, we can actually guide the market to account for its own blind spots. Market forces are amazing analytical tools when they're properly redirected. But it really leaves us to wonder, as our world becomes infinitely more complex, what totally new, invisible costs and benefits are tomorrow's digital networks going to reveal? And more importantly, how are we going to choose to solve them? Thanks so much for joining me on this explainer. Keep analyzing, and I'll catch you next time.